Good morning, everyone. Unlike me, this is going to be very short. What I wanted to talk about was our approach towards solving data-centric problems first through a visualization, right? I mean, this is the typical flow that we as data scientists take. We visualize the problem. We help business users visualize the same problem that we are seeing, and we understand what kind of decisions are they making. Are they choosing door one or door two, right? And then we make a study of those decisions, and then we build it into some kind of either logical algorithm or some kind of a machine learning algorithms, right? So ideally, so this is a very dynamic data set, and I will tell you how we've used this for one particular use case, which is freight matching, right? So any data set, right? We convert that into a data set of decisions, which business users come up with, right? And then that gets converted into an automated algorithm. Now, what am I talking about when I'm talking about the approach, right? What we typically do is a ground up approach, which relies heavily on what kind of variables are there in the data set rather than looking at it as a charting problem, right? So if you look at visualization as a charting problem, you are limited by what is available to you in either the BI tool that you're using or any charting library that you're using. When you're building things from ground up using, see, there are a lot of very powerful JavaScript or Python libraries for it, right? There is D3, which is available in JavaScript. There is processing, which is available in Python. What that helps is transferring the kind of insights that you want directly to a business user, that it is visible to him as some sort of a attribute, some sort of a visual attribute, right? So first you look at the data set, and there is a very interesting paper by Colin Ware which talks about pre-attentive attributes, which basically are in 4 different categories, which is color, form, some sort of spatial features like position, right, and movement, right, and all everything that you talk about, like shape or length or width or collinearity, form some sort of a subcategory of each of these, right? Or if you look at color, there are further subcategories of color like hue, saturation, lighting. So once you once you uh, understand this sort of a split of pre-attentive attributes, whenever you see any visualization, you try and decode what the person who's built the visualization wanted you to read in the first place, right? Then you look at the detailing which is required. When you when you have to encode information for a business user to decode, you also have to know up to what grain that he wants to go. And finally, and this is one of the most key areas actually, is the design choices that you're making. Are you going to use multiple hues in the color scale that you're using? Are you going to take a linear scale, or is it going to be a log scale? What is the kind of values which are there, right? So here it is not just a data science problem, it's also a design problem, it's also a UX problem, it is also a psychology problem, it's also a consumer behavior problem, right? So I'll talk about how we've done this for one particular use case that we had, which is freight matching. Talking a little bit about Pickle.com, we are a 3PL service provider for sensitive cargo, right? So we ship white goods, furniture, and certain sensitive cargo like ATMs, servers, things like that, right? So we get a lot of long haul LTL loads. When I say LTL, it means less than one truckload, right? So it is important for us to be able to visualize what kind of load, what are the kind of loads which are coming in a similar date range and in a similar territory, so that we will be able to couple them and send. So this also is a purchases problem for us, because the purchasing team is not able to visualize what kind of loads are there, which is there between two cities. So once there is a data set which is coming up, which shows how costs come down drastically over the larger load size in a long haul scenario. So it also gives the purchases team the ability to forecast what kind of truckloads we'll have to place, right? So if we, so roughly this is how it is going to be. Like there are multiple ports where shipments keep coming in a very random Poisson process, right? So it's a chicken and egg problem for us. We cannot cut costs without volume going up. We cannot, get volume without cutting the price, right? So if you look at the typical total cost, which is to be and compare it against shipment size, it comes down exponentially over time, right? And the marginal cost for a volume of shipment is almost asymptotic, right? And the curious case is that the smaller trucks can be sent only for a smaller distance. So over smaller distances, the aggregation opportunities are smaller, but over a larger distance, it becomes increasingly more, right? If you look at an international use case, there are loads that we can couple actually from multiple cities coming to a same port, then aggregate and send to the destination country, and then split the shipment from there. Another problem that we have is that the demand patterns are highly skewed, right? Even though the net average demand for the company is more or less the same, but channel-wise demand is heavily dependent on projects. Let's say if we get a project suddenly to deliver 200 shipments in Delhi, it just comes in a very seasonal manner. So this is the data set that we are talking about. We map the city locations, we have the places, and we have the location attributes, and we have the load data between city on. We have days. So the problem is basically find loads given that some other loads are already in. You already have loads for certain territories. So if I break down the data set, it looks something like this, right? Now I look at the pre-attentive attributes. We look at 7 of them, which we very commonly use, which is color, position, movement, sizes, shape, orientation, and pattern are not. So these are some of the typical ones. There are others like collinearity, which do not translate very quickly on a UI. So after that, we looked at what kind of detailing we need for each of these, right? And what is it that the business users want to see? Business users wanted to see what are the loads which are going to come up in a particular channel. What are the loads which are originating from a particular port at a particular date, right? And so some sort of visualization on how what the type of loads which are going to come in a particular date. So this was the first step we took. We what are the very obvious encodings which are possible, right? Positions can be encoded. I mean, the lat long can be encoded as a position on a 2D scale. The shape is basically a line, a curved line from point 1 to point 2. And then ports are encoded as circles, right? So we started off with this. So this is a very iterative step-by-step process. So I'm skipping a few steps here because we are short on time, right? So when it was a smaller data set, it was fairly easy for them to visualize. There were like 4 or 5 lines from Bangalore. But once we started operations in other cities, this became slightly cumbersome for them also, right? And so then we decided to, so they wanted to see what is the aggregation rate, right? So we encoded that as a single hue and with multiple lighting based on a scale of 0 to 100%, right? What they said was that this does not work for us. You either give us yes or no decision. These are go no go decisions for us, right? So we encoded them into a 2-color scale, whereas we felt the lightness comparatively going from lighter to darker shade would give them a better view. But this was something that business came back to us and told, right? So in this context, they were also losing the context of where certain nodes are going. Is that Kolkata or is that Bhubaneswar, right? So they wanted us to encode this whole thing inside a map. So that's when we started with this. And then what we decided was that they couldn't see. We're not a big fan of using movement inside visualizations, but in this case, it works because it directly shows the movement of goods from point A to point B, right? So, and to add to that, we gave them more drill down features, and we also gave them a voice interface so that they can talk to it, right? Tell me all loads between Bangalore and Pune, and it'll just suddenly pop up with all the loads which can be coupled, right? So, so once we did this, right, we once we looked at the decisions that they were taking, we got some very simple heuristics that they came and talked to us about. If they see a green line, they click it. If they see a very thick orange line, they click it. So this forms an input for us to build optimization algorithms and figure out, where all can we build these. How do we go about building these things? So this was built with D3 and Dialogflow, and the code is available in a GitHub repository. You can go and check that. So once we did this, we saw that the volume was significantly going up. The cost per shipment had come down, but we were able to cut price even more than that, and still got a revenue uptick. So these are the two papers that I mentioned. One was by Colin Ware, and the other by Stephen Few. Thanks. I'm up for questions.
Can you also talk about how the interface and the interactions was, like the voice interaction that you said? Do you have it? Can we see it?
Yeah, let me just check if. Just give me a minute.
Excuse me, I have another question.
Yeah.
Yeah, here.
Yeah.
So you were saying that it's a chicken and egg problem
Yeah.
about the transportation and how much we are covering. So in the starting, do we have any criteria that in the starting, if my volume is say 10 in this area, my cost can go up to 50% or 100%, but with time it will come to 50% or 20%. Do you have any numbers around it? That my target is this much, and my volume will increase this much, it will be decreased by X amount, right?
Yeah, yeah. So that was one of the slides that I had shown, which is basically, yeah. See, in time, actually, the cost does not go up drastically or come down drastically because these are long haul shipments that we are talking about. So beyond a point, there are not a lot of visualization, there are not a lot of optimizations that you can do on long haul logistics cost, because it is just not possible to send a 120 feet container in roads in India, right? You have to split it into 3 40-foot containers if you have that big a load, right? So, so it over a longer period of time, it becomes very constant. So there is a very, in this particular case, right, there is a big, so between a 40 feet and a 120 feet, there is not a lot of difference in marginal cost. The cost of sending 40 feet and the extra 80 feet of load is more or less steady. But the cost between an ACE, let's say 200 cubic feet size and a 1000 cubic feet size comes down drastically. That is this area here, right? So basically the incremental cost is basically the area under that curve. So the area under that curve beyond that point is more or less constant. But in the beginning portion, it comes down drastically.
So when you decide the pricing for these, how do you do that? Like, because in the starting, you don't know what's the volume, right? So you obviously take the maximum, the minimum possibility of it. But then how do you, what's your margin and all? Like, what's the upskill which you take?
Understood. So what we typically do is, see, we know that the arrival of loads is going to be in a Poisson distribution, right? So we kind of, but beyond that, where is that load going to come for is basically fairly random. So we run a few simulations and try and figure out how many loads we are likely to get, but we know that the load size are going to be in the top 6 cities in India for us, right? So once we know that distribution, we try and forecast that piece, right? So I mean, on top of this, what we are building is that kind of a prediction model, which says that between 31st and 2nd of December, I'm likely to get 4,000 cubic feet of requirements from Bangalore to Delhi channel, right? Based on that, we place the truck requirements accordingly. Yes, drastically, because I mean that is one part of it which we cannot predict, which is there are some external factors which affects the costing, which is petrol prices for one.